Siyathemba
Sanibonani grade 12 sesihlangene futhi for physical sciences. Siqhubeka la sigcine khona last time sikhuluma ngama reaction rate, sachaza ukuthi yini reaction rate. Kodwa siqale sakhuluma ngama endothermic exothermic reaction, then sakhuluma nge-collision theory, and then safika lapho kumele sikhulume ngama reaction rate. Then before siqhubeke sithi ukukhumbula sithethe reaction rate will be defined as the change in the concentration of ama reactant noma ama product per unit time, right? So ileyo definition edingakalayo, the reaction rate, right? The change, so the delta, the change, the delta, you know, the change of what? Concentration. The square bracket means concentration of ama reactant. Kungaba ama reactant noma kube ama products per unit time. Per unit time. Ama unit for time will be ama second, noma ama minute, noma ama hours. But most of the time, it's ama second or ama minute. Right? Even the years are also what unit of time. Noma decade, noma century, still, or noma millennium. Say unit of time. But it gets 7 salam, the second. Right. Kwi reaction rate, sibona ukuthi i-reaction rate ingaphuma i-positive noma iphume i-negative. Kuya depend ukuthi wena usebenzisa ipart lama reactant noma usebenzisa ipart lama product. Usebenzisa ipart lama product. So it's all about that. Ma usebenzisa ipart yama reactant, into siyaziyo ukuthi ama reactant ayancipha vele makwenzeka i-reaction. So mencipha kusho ukuthi azoqala la wehle, mhlambe azophela noma mengapheli azogcina somewhere, right? Kusho ukuthi agcina la. Then kuma product, ngoba siyazi ukuthi reaction mayiqala vele akukho lutho kwi-container, but mase kuqhubeka nje i-reaction uzobona ukuthi ama products ayaformeka ke manje nawo, then you have ama product. At the same time makuphela ama reactant, ama product nawo aba constant. I-value yakhona iba constant ngoba akusaformeki lutho. So it is a horizontal line. Sithi the reaction has reached completion, right? Or one of the reactant have been used up. The one that has been used up sibiza ngani nge-limiting reagent, right? Sithe futhi masicalculator sibona ukuthi usuka la uza la, right? So from i-reaction noma i-formula sinayo ngala izokhiphela ukuthi sine change in y over change in x. Lokho kusinika bani i-gradient ngokwe-math, right? Now sinendlela esuthu uzocalculate i-reaction rate. The first one ubuka i-average reaction rate. The second one kungaba instantaneous reaction rate. Most of the time we calculate instantaneous reaction rate bakunika i-graph khona uzoyisebenzisa leyo graph ukuthola i-reaction rate at a specific time, right? Ngala mawuthi average reaction rate, for average reaction rate wenza njani? Uthatha final amount minus initial amount. Ukuthi inkinga le ukuthi it's a curve, akuyona bani a straight line. So kusho ukuthi ma ucalculator i-gradient, uyabona ukuthi i-gradient between this point and this one is not the same mawusuka la uzala. A, point A, point B, point C. So uzobona ukuthi the gradient between A and B is not the same as between B and C. So that makes ukuthi sibe nani nama reactant ama gradient amaningi. It will always depend from ama values unawo, right? Because it is a curve. Now what the next thing you need to look at ukuthi makuthiwa calculate average reaction rate. Average reaction rate, uzohlezi usebenzisa bani i-final amount minus i-initial amount. Nge-amount sayichaza last time uthi masikhuluma nge-amount sikhuluma mhlambe ngama number of moles, noma sikhuluma nge-mass, noma sikhuluma nge-concentration, noma sikhuluma nge-volume of gases. Right, so ingaba lokhu thathi final minus initial. Awubuki ukuthi kusuka kephi kuya kuhamba ngakephi into like masibuka le graph, so thathi i-amount ela izoba i-initial amount. Le amount ela corresponda na lesikhathi sokuthi ama reactant aphelile. So this is your final amount. Ukuthi kuhambe kuphela kanjani, that is not a problem ngoba sicalculate yini i-average. Same thing happens kule. Right, this will be your initial amount or 0. The final amount will be the amount that correspond to the horizontal line gala. So this is your final amount. Lapho ucalculate any average reaction rate. Right, asithi example hlambe la 45 second udelta t wethu in second, udelta t in second. So lokhu kufomeka after 5 second. Kusho ukuthi i-reaction rate i-reaction yethu iphela after 5 seconds. So into ezobona ukuthi what if kuthiwa calculate the reaction rate at this point here, at this time. This time is 1,5 second. At this point, itini reaction rate at this particular point only. So yabona ukuthi sekunzima ukuthola i-reaction rate on 1 point ngoba siyazi ukuthi kumele sicalculate i-gradient. I-gradient sidinga ama-point awu-2. Kodwa nje kuthiwa at this point akusiyona i-average reaction rate instantaneous ngoba sifuna at this specific time. Manje wenza njani mona icase enje? Right? Into fanele uyenze wena udweba i-tangent. Siyakhumbula i-tangent nge-math udweba i-tangent, a straight line that will touch this curve at only 1 point. Udweba i-tangent. Masu udweba i-tangent sungacalculate i-gradient yaleyo tangent izokunika bani leyo reaction rate. Just try to draw the tangent. Noma ngala makunjena hlambe at point B, when I just draw a tangent, you draw a straight line ezothinta leyo point kuphela, then you calculate the gradient. Vele gradient uyakwazi ucalculate, you can just pick any 2 point, then so your calculator change in y over change in x. Right? I hope siyazwana. Now umona kanjani futhi i-reaction rate maso compare shake uthi khona i-reaction fast noma i-reaction slow. Lokhu ubona ngani? Ubona ngokwe gradient. The greater the slope kusho ukuthi the greater the reaction rate. I-reaction rate angithi uyabona ukuthi it is per unit time. Lokhu kuyakutshela ukuthi makuthi per unit time mathematically ungathi kanjani ukuthi i-reaction rate is inversely proportional to the time. But asisho lokho, sisho ukuthi makunesikhathi esincane kusho ukuthi le reaction yakho i-fast. Kusho ukuthi i-reaction eshesha ngokuphela iyona i-fast. So it's not ukuthi ngoba le reaction thathu 10 minutes yona ine rate of reaction enkulu. I-rate of reaction ihamba nesikhathi esincane. The shorter the time it takes to reach completion, the greater the reaction rate. Right? So kunjalo kumanjalo ke mase ucalculate. So average, just look for a final value, the initial value. Final time, initial time. Kota makuzoba nje at a specific time. Mhlambe soyibiza ngani instantaneous reaction rate. Into fanele uyenze wena dweba nje i-tangent to that point, and then ucalculate i-gradient yaleyo straight line yaleyo tangent. Then uzobona ukuthi I know ukavekile uthole kahle i-answer yakho. Right, so that is for the reaction rate. Manje ke asibuke ukuthi le reaction rate kahle yenziwa ini? Enziwa ukuthi ama particles kumele enze njani collide. Those particles angisibuyela muva ku collision theory. Sathi collision theory ukuze kwenzeke i-reaction, right, kumele ama particles ashayisane, then ukushayisana kwabo kumele kukhiphe ini kwenzeke ukuthi kube ne breaking of bond and forming of new bond. Makungekho lokho futhi ngeke kwenzeke ini i chemical reaction. ama-particles fanele a-absorbe i-energy enkulu noma elingana nani ne-activation energy. I hope nisakhumbula i-activation energy ngesikhathi sidweba i-graph ye-exothermic ne-endothermic reaction. So at that point sothini masibuka-ke i-rate of reaction, sifuna ukubona ama-factors that will affect the reaction rate. Ama-factors affecting reaction rate. Right. Nama factors that will affect reaction rate. Why sithi azo affect a reaction rate? Ingoba azokwenza ukuthi i-reaction isheshe iphele noma ithatha isikhathi ukuze iziphele. So that is the masithi i-reaction rate. Right. Masibuka ngama factors. We look at 6 factors. Funa ukuwabhala wonke at the same time so that siwachazake one by one. The first one esikhulume nge-temperature. Temperature is the number 1. The temperature is one of the factors affecting the reaction rate. Number 2, sihamba nge-concentration. The concentration is one of the factors affecting the reaction rate. Number 3, sine pressure. The pressure is also one of the factors affecting a reaction rate. Number 4, singakhuluma ngani nge-surface area. I-surface area noma ibizwa nge-state of division. State of division is also a factor that affects a reaction rate. Then number 5, sokhuluma nge-catalyst. Yakhumbula sakhuluma nge-catalyst last time. Then number 6 will be the nature of reactant. Nature of reactant. Right. Nature of reactant. So these are the 6 factors esizowazi ukudila nawo. Manje lama factors why sithi when affect i-reaction rate ingoba ane impact kwisikhathi se-reaction. I-temperature izo affect i-reaction rate. Because i-temperature yakwazi kwenza ukuthi i-reaction yakho isheshe iphele noma yenze njani ithatha isikhathi. Concentration is same thing. Concentration yama-reactant. Right, ama-reactant affect a-reactayo ukuthi makune concentration siphethe inani. Manje sobona ukuthi makwenzeka i-reaction we have 4 types of substances esidila ngazo at this point. Right, i-substance ingaba i-solid sithi u-S simfake kanje, noma i-substance ingaba i-liquid, noma i-substance ingaba i-aqueous solution, noma ingaba i-gas. Right, so these are the 4 types of substances esidila ngazo at high school level. Kungaba i-solid, kube i-liquid, kube i-aqueous noma kube i-gas. Lama factors wonke lana sikhuluma ngento idila nani nama-reactant akhambisani no product. I-product ayindayo ngoba vele product ayina impact kwi-reaction rate. Right, so i-temperature can affect i-rate of reaction. So uma ukuthi ama-reactant angaba ama-solid, a-liquid, aqueous noma i-gas, kusho ukuthi i-temperature yona isebenza kephi to all of them, whether it's a solid, noma liquid, noma aqueous, noma gas. So temperature will affect ama-reactant in whatever phase akuwona. Concentration. Concentration will affect ama-aqueous kuphela nama gases. So for concentration is applicable for aqueous solution and for gases. For pressure, this one only, right? Gases only. Kumele sibe specific lana, gases only. Surface area, loku kuzohambisana nani? Ne solid, right? Solid only. Still ne solid only. Catalyst. Catalyst, angizithe substance that speed up the reaction. Uyabona ukuthi say it's so related kuma reaction rate. Uthi ya speed up, ama uthi speed up kusho ukuthi izoshesha iphele, isikhathi siyangena lapho. So i-catalyst nayo affect. Manje ma add i-catalyst akuhambisana nokuthi ite aqueous noma ite liquid ngoba vele aku-react nako. Kusho ukuthi i-catalyst nayo ingena kephi to all. Right, mase siba ne-nature of reactant. Kahle le ndaba ye-nature of reactant ukuthi asikwazi thina kuyishintsha ngoba it depend kule nature yema-reactant unawo. Awukwazi ukushintsha i-nature ye-reactant eyodwa mhlambe uyi-affect ngoba if ngikhuluma mhlambe nge-reaction of zinc nani no HCl, right, akufani nokuthi ngisebenzisa bani umagnesium no HCl. So i-reactivity ka-magnesium ne zinc akufani. Noma mhlambe i-acid ithe monoprotic acid u-HCl angeke kufane ne-reaction kabani mangi-reacta nano H2SO4. Lo HCl ubani uyi-monoprotic, lo H2SO4 u-diprotic. Yabona ukuthi sikhuluma ngento engafani kahle. So angikwazi ukushintsha i-nature ka-zinc ukuthi angazi ngizoyenza i-zinc enjani, u-zinc light noma u-zinc bani. So zinc is just zinc. There's nothing I can say ukuthi this is a second variant ka-zinc. So u-zinc, so we cannot change it. Ukushintsha i-nature kusho ukuthi ngiyashintsha u-zinc ngifaka enye metal, mhlambe ngifake u-copper noma ngifake i-aluminium noma ngifaka bani magnesium. Lapho ke singizothi I've changed the nature of the reactant. So nakhona it still give us what effect kubani kwi-reaction rate. Right, manje ke lama factors lawa affecta kanjani i-reaction rate. The only thing esoyibuka ngayo ukuthi affecta i-reaction rate ingoba lama factors lawa affecta i-collision. Kumbula le part ye-collision theory, we need to have an effective collision. Sazobuyela kulama factors sithini, so khuluma ngalama factors, it always going with i-collision theory. I-collision theory isho ukuthi for the reaction to take place noma for a reaction kuba nama breaking of bond kumele kube khona ini effective collision. Kube khona ama effective collision. Now ama condition for effective collision kumele kube nani? Sufficient kinetic energy, dingekala leyo. Sufficient kinetic energy zoti EK, mese kube nani ne correct orientation. So that is these are the two conditions for an effective collision, right? The sufficient kinetic energy and the correct orientation. So if you look at that one, zobona ukuthi masine sufficient kinetic energy then sine correct orientation, mase sifaka manje ini iskati, masifake iskati, masizoba nama effective collision ngesikhathi esifushane, kusho ukuthi nale reaction yethu izoba fast. Kodwa mokuthi sinama effective collision amancane, then i-reaction yethu nayo izothatha isikhathi, then we'll say it has a faster, you have a faster reaction noma you have a slower reaction. So wonke lama factors kwa temperature, kwa concentration, kwa pressure, surface area ne catalyst, sifuna ukubona ukuthi wona lama factors affecta kanjani reaction rate using i-collision theory. Right, into ngizokutshela yona ukuthi mawubuka lama factors wonke ungawachaza ngendlela ecishe ifane, ingoba kumele ube ne strategy sokuphendula. Ungaze ubhale into eziningi, mhlambe ubhala ama paragraph awu6 kanti awushongo lutho noma usho into eyodwa uyiphinde ngenye indlela, but kumele wenze njani, wenze sure ukuthi ushaya khona ngqo, right, ma u-explainer in terms of collision theory. Right, now asibuke the first one. The first one is a temperature. I-temperature affecta kanjani i-reaction rate. Right, the first point ekumele ukhulume ngayo ufana ukhulume nge-fact. The fact ukuthi wonke lama factors aya increase i-reaction rate mawuthi uyawa increase. That is the first fact. So yabona ke lokhu kumele ukusho njalo uzothi an increase in temperature will increase the rate of reaction. An increase in concentration will increase the rate of reaction. An increase in pressure will increase the rate of reaction. Increase in surface area will increase the rate of reaction. An addition of a catalyst will increase the rate of reaction, right? Ngicina lana ngoba ngishilo mina about nature. Angikwazi kusho ukuthi an increase in the nature noma increase in the zinc. Angazi ukuthi uzinc ngamenzani. Uzinc nje, right? So I cannot change that nature in a reactivity yakhe, right? So ngakhuluma ngokunye ingakho ngicina ku number 5 we catalyst. Kodwa nje in nature I hope ni understandile ukuthi zinc ne copper, for example, which one is more reactive? Nigena sebenzisa lama table lawa u4B no 4A kwi electrochemistry. So ngabona ke between zinc and copper which one is more reactive. So le reactive metal yona izokhiphela i reaction rate fast. So for this reaction khona into efanayo for all of them. So mangikhuluma nge temperature ngizothi the temperature, an increase in temperature will increase a reaction rate. So noma kuthiwa ukuthi uchaza ngani nge concentration uzosho the same thing. So bullet 1, its increase in temperature will increase the rate of reaction. Mangichaza nge concentration nakho ngizothi makuthi it's about concentration ngizothi increase in concentration, an increase in the concentration of the reactant will increase in reaction rate. Mangikhuluma nge pressure ngizosho same thing, an increase in concentration of an increase in the pressure, right, of the reactant will increase a reaction rate. Mangikhuluma nge surface area ngizothi an increase in surface area. So ngizochaza nge temperature kuphela mesibona ukuthi siku apply kanjani ku wonke lama factors. The second thing kumele sikhulume ngale temperature yakhona. Sithi senze ngathi siyayidefine. I temperature is the average. Temperature is the average kinetic energy, right? Or is the measure of the average kinetic energy of the particle. Average kinetic energy, right, of particles. Angisi mesichaza ngala, what is at the back of our mind is collision theory. Manje I temperature vele yona it's the average kinetic energy of the. So kushokuthini when you increasing temperature, that's what increases the kinetic energy. Mese sibuyela kubani kwi collision theory. Increasing in temperature will increase what? The kinetic energy. Collision theory itini ama collisions kumele abe nani ne sufficient kinetic energy. Kale sidinga ini effective collision ngoba no akusiwona wonke ama collision azokhiphela ini collision effective collision. Effective collision ile collision zokhiphela bani ama particles ane sufficient kinetic energy futhi akollide ngani nge correct orientation. So already ngala siyabona ukuthi payona temperature yona it defines ama average kinetic energy of the particles. So mawuthi uya increase yona kusho ukuthi I kinetic energy of the particles will increase, right? Kusho ukuthi we have more particles, sekuna more particles with sufficient kinetic energy. Mawuthi na more particles kusho ukuthi there will be what? More effective collisions. Now angithi manje sikhuluma ngani nge effective collision. Sithi more sewumaningi ke manje effective collision. Njengoba sikhuluma nge reaction rate, si define reaction rate as the change in the reactant or concentration of reactant or product per unit time. So lokhu ingoba kuhambisana nama effective collision per unit time. So sothi egcineni more effective collision per unit time. Okugcina lokhu. If you do this for all the other factors, angeke ube wrong. So we always talk about the same thing. The first bullet uthi uyasho effect ukuthi by increasing lokhu, the rate of reaction will increase. For all of them, njengoba ngishilo, makhuluma nge-temperature, increasing temperature increases the rate of reaction. Increasing concentration, rate of reaction increase. Increasing pressure, rate of reaction increase. Increasing surface area, rate of reaction increase. Adding a catalyst, rate of reaction increase. So it's effect for all of them. And kumele ukusho njalo makuthiwa explain how the temperature will increase the rate of reaction. Right? So ngokwe temperature ngithe the first one, an increase in temperature will increase the reaction rate. The second one, ngiyazama ukuchaza yini temperature kahle kahle. So ngibona ukuthi temperature is the average kinetic energy of the particles. Right? Average kinetic. So uma ukuthi ngiya increase I temperature kusho ukuthi ngiyenze njani? Ngiya increase I kinetic energy of the particle. Vele kinetic energy is part of ama conditions for effective collision. So ngizothi sekunama particles amaningi anani ane sufficient kinetic energy kusho ukuthi azo collide effectively, then ekugcineni ngiqeda ngani nge more effective collision per unit time. Yabo bullet 1 and the last one kuyafana for all of them. Kuyafana for all of them. We start with increasing with this one, then ugcina ngani. Therefore, they are more effective collision per unit time. Go more effective collision per unit time. Usho kahle ukuthi there is an increase in the reaction rate. Right. So mfuna uyibukeke at that point mase sibuka ngani nge concentration. Asibuka nge concentration. Sibe sibuka concentration ngapha ne temperature. Step bullet 1. An increase in temperature will increase the rate of reaction. Mawi concentration an increase in concentration will increase the rate of reaction. Number 2 we temperature stay. The temperature is the average kinetic energy of the particle. Mese lana ngoba sikhuluma nge concentration. Siyayidefine leyo concentration. Concentration is the number of particles per unit volume. Angit. Number of particles per unit volume. So you understand that. Now the third point, increasing in temperature. Now siyashoke ngoba sechazela ukuthi yini temperature. Manje sibuyela futhi kuleyo yokuqala ukuthi mase si increase leyo nto leyo kwenzekalani. So ngala njengoba sishilo ukuthi concentration is the number of particles per unit volume. So mase increase leyo concentration leyo, what will happen? Right? So angizithe a number of particles per unit volume. So kusho ukuthi when I increase concentration, increasing concentration izoyenza njani? Izo increase the number of moles per number of particles per unit volume. So kusho ukuthi there are too many collisions azowenzeka ngoba maningi manje per unit volume. So that is the following point. So increasing concentration will increase the number of particles. Kusho ukuthi point number 3 ihambisana no point number 2. Uyasho ukuthi mase si increase concentration point number 2 wona wenza njani, because point number 2 wona uchaza ile factor leyo. Njengoba sithi a concentration refers to the number of particles per unit volume. So makuthi siya increase concentration kusho ukuthini? Kusho ukuthi si increase in number ya particles in that particular volume. Makuthi maningi ke mase siza ku point number 4. When there are more particles per unit volume, sesina more collisions. Sesina more collision ngoba maningi phela ama particles kwi volume eyodwa. Right, mase khuluma nga more collision vele kusho ukuthi sizoba nani ne more effective collisions per unit time. Ngoba maningi vele definitely ngoba amaningi ama collision so thola nama effective collision per unit time amaningi. More effective collisions per unit time. Kiyafana nakhona, same thing. Right? So you have to look at that point. Makuthi mhlambe ngizothi asibukeke the third one, so pressure. Same thing. Sikhuluma nge pressure. Nayo so landela the same thing. So temperature, pressure, an increase in pressure will increase the rate of reaction. An increase in pressure will increase the rate of reaction. That one is common for all of them. right? So an increase in pressure will increase the rate of reaction. Mese siyachaza-ke ini i-pressure, right? Now, the pressure is the number of collision of the particles among themselves and between the surface of the container, right? So if we increase the pressure, a number of collisions will also increase. So we have more collisions taking place in that container. Masina more collisions, we have more effective collisions per unit time. Now futhi siyayithola kanjalo. Then I still leave the concentration part here. Sibuga the third one, that will be a surface area. In the surface area, right? So Sibuga is surface area. Again, bullet number 1, increasing the surface area will increase the rate of reaction. The same way skulumengani get temperature. Increasing in temperature will increase the rate of reaction. So increasing the surface area will also increase the rate of reaction. Right. So maguna loku ke ungabona ukuthi you can now apply this. See point number 2. What is a surface area? Right. The surface area refers to what? The number of particles that are exposed in a reaction. Right. The number of particles that are exposed. Then mabuti city increasing the surface area. Bullet number 3 nagelo. Increasing the surface area kushogutini is to increase the number of particles that are exposed. Kushoguti ama number of particles as a collider. So we have more particles that are colliding. Therefore, there is more effective collisions per unit time. Ngishilo ukuthi le part yokugcina, don't leave it out. The first one and the last one. Noma ke nalo last one or the first one ungamfaka egcineni, it's fine. Kodwa ke mawukuthi explain using collision theory, don't miss this point, don't miss this point. And increase this effect, right? Low increase ungambeka la noma umbeke la egcineni, it's fine. Kodwa ukhulume ngaye ke ukuthi an increase, that is the effect. Uyasho ke because kuthiwa explain, right, what's happening. Noma kuthiwa this reaction here was taking place at 25 degrees Celsius. This one took place at 30 degrees Celsius. Which reaction will be faster, or which one has a higher rate of reaction? So kuluma ke ngalokho. Because this one has an increase in temperature. So a greater temperature increases what? The average kinetic energy. If you have an increase in the average kinetic energy of the particles, then you have more particles with sufficient kinetic energy. Therefore, you have more effective collision per unit time. Ingako in increase in temperature noma uzoti. So you conclude that ingako experiment 2 is over a higher reaction rate than experiment 1, something like that. Right. So for surface area na corner, same thing. The first point, show effect with an increase in surface area will increase the reaction rate. So for surface area, when we increase the surface area, lapo guti uthola a substance is solid, ngite surface area is acting kuma solid depend. So depend ukuthi u increase kanjani surface area, right? So when you have a chunk of a metal, or of a salt, normal is in a powder like. So the pieces that you have, if it's in pieces, then you have what? More surface area. Meaning ama particles are exposed. Mawuzama uchaze surface area, right? Outing tate a glass, and then I put it water in. Mese ngifaka ini hlambe a piece of a metal like this, right? Into ngizobona ukuthi lamanzi lawo noma le substance ele ithinta this side ngala at the back, right? Let's say it's floating, even at the bottom. So how many surfaces? 1, 2, 3, 4, 5, 6 surfaces are in contact for this one, right? Now ngifuna increase a surface area. Angithi lamanzi lawa are in contact with only this part avelayo. Now what if I break this one into pieces? This same piece, but this time ngivele ngithi no, outing thathe lo piece owodwa ngimuthi kanje then ngithi hlambe the second one yabo sengiyikhathe into 3 pieces, then the other one, right? Because mase ngihlanganisa laba u3 bangikhiphela into efana nale. Now this time I do what? I break it into 3 pieces. Now buka ke lamanzi lawa azothinta into engakanani. So khona le surface ngala iphinde ithinte ngala, iphinde at the bottom ithinte ngala, imthinte ngala, imthinte ngala. Ithi kanje futhi 1 2 3 4 5 6 1 2 3. So ubona ukuthi amanzi are more in contact with more particles of this one. So if I cut them again into pieces, the more I break them down into smaller pieces, the more particles are visible or are exposed to the surrounding substance. But ngiyathemba ukuthi seni understand in the surface area. So kuba njalo makuthiwa this one is a lump of something, mase kuthiwa this one is in powder. The one is in powder is having a more surface area than the one in lump. Right? So that is how you look at the surface area. Then the other one, the other factor, catalyst. Catalyst. The same way sikuchaza nge-temperature, the same way sikuchaza ngani nge-catalyst. In addition of a catalyst, singathi uthi an increase, as increase catalyst, I add a catalyst, right? An increase, I mean, an addition of a catalyst, right, will increase the rate of reaction. Mese wesibili siyachaza-ke what is a catalyst, right? So asizoyidefine ngokuthi it speed up a reaction ngoba very sifuna ukuchaza how does it speed up the reaction ngoba kwale temperature nayo kwale temperature nayo ya increase ya speed up in a reaction. When you increase the temperature, the reaction speeds up, right? So if we catalyst, so number 2, the catalyst does what? Decreases or lowers the activation energy by giving an alternative path for the reaction. So gashatento sibuka kakhulu ukuthi i-catalyst izo ehlisa i-activation energy. Yakhumbula le graph, right? So i-catalyst mawukuthi akho catalyst ama-particles kumele akhave leyo energy le. Makufaka i-catalyst then sekune shortcut ke ngana. Kune shortcut ngapha. So angithi uyabona ukuthi activation energy si lower compared to this one. Lama particles lawa bekumele aze afike la angakwazanga ukufika sekuzoba lula ke mawukuthi mhlambe i-activation energy sambe ku 60 joules. Akhona ama particles ano 40 ano 55 kodwa awakwazi ukuthola i-sufficient kinetic energy ngoba ku below bani i-activation energy. So kodwa mangithi siyayilowerisha ke le activation energy thambe ngilethe ku 40, right? So yabona ke wonke lama particles kade ano 50 ano 47 ano 45 ano 58 wonke ke manje azobenze njani azoba naleyo energy edingakalayo. So you will have more particles with enough or sufficient kinetic energy ukuze kwenzeke i-reaction. Then ugcina ukuthi then therefore there will be more effective collisions per unit time. So chaza kanjalo ke mokuchaza wonke lama factors. So in Toyota you have the same strategy that will apply for all of them. Makumele uchaze what is the reaction rate, right? That sinike part temperature kuphela, but that we can apply to all the other factors. Concentration, pressure, pressure, catalyst, surface area, right? And temperature, right? Stay as so kuluma kulunge nature. I ngoba I affected cotton now. I affect in a sense that externally asikwazi kushintsha nature of a substance. Kwa temperature siyakwazi increase the temperature of a substance. Kwa concentration siyakwazi increase the concentration. We add more particles to a substance for the same volume. Sesiyazi ukuthi ayisesi increase the temperature. For the pressure siyakwazi increase the pressure by reducing the volume, right? When it's a gas. by reducing the volume. Niyakhumbula i-Boyle's law grade 11, right? So siyakwazi increase i-pressure. For surface area, siyakwazi increase the surface area because we can break down a substance even in powder, right? So we siyakwazi. For a catalyst, siyakwazi add the catalyst. Kodwa for nature of the reactant, asikwazi kuyishintsha i-zinc angazi ibe njani, but siyakwazi kuyishintsha na sifake enye substance, akusiyona the same substance. So it's not the same substance, we use a different substance. Mhlambe that is more reactive or less reactive than that one, right? Ukuze senze njani ku affecteke ini i-rate of reaction, right? So after ama factors sesingabuka ke okunye ukuthi how sibuka kanjani in terms of a rate of reaction. Then ukhona scientist uthi ubizwa ngani uBoltzmann, Maxwell Boltzmann wafaka ama curves, distribution curves, right? Awu 3 ama curves akhe achaza ukuthi how a temperature noma how these factors will affect the rate of reaction, right? Uchaze ngendlela eziwu-3. The first one ukhuluma ngani nge-temperature, right? I-graph yakhe yokuqala ihamba ne-temperature, yesibili ihamba ne-concentration, nesithathu ihamba nani ne-catalyst. It's all about i-activation energy, i-catalyst, right? Ngizokwenza konke at the same time, i-catalyst. So for i-temperature une-graph ngala number of particles, ngala concentration, ngala une-energy. So at this point i-activation energy ila nanti futhi activation energy. So siza ngala ku-catalyst same thing, i-activation energy sifaka ngala ngoba kuma x-axis sinani sine energy. I-activation energy sakhumbula ukuthi activation energy is the minimum energy that allows what the reaction to take place, right? Then uchaza ngokuthi ama particles masiwafaka mhlambe kuyi-graph it is like ngala sithi nazo ngala nakhona sithi something like this, nala sithi something like this. So into sibona ukuthi lana kuna ama particles, nala futhi kuna ama particles, nala kuna ama particles. Kodwa ke kule reaction only ama particles ane energy greater than activation energy azo-react, right? So masibuka leyo nto uzobona ukuthi lo activation energy mangithi kanje ilama particles ngala angaka right iwona asinika bani azo reactor noma azophenduka i-react ama product ngoba i-energy yawo inkulu kune activation energy. Lawo asane energy lower than activation rate, so they are not taking part into the reaction for now. Then ngala same thing, activation energy ila, so only ama particles angala on the right side of the activation energy azongena ku reaction. For a catalyst same thing, right? Activation energy engala. So in terms of temperature uyashwe nokuthi by increasing the temperatures the kinetic energy of particles does what will increase. So wonke lama particles ala azoyenzenjani, most of them azo shift amount to increase the temperature kusho ukuthi le particle le njengoba seduze ngala izothi shwi ngala nale ithi ngala nale imove ngala. So uyabona ukuthi i-shape of this graph izoshintsha kahle, so ayizosala kanjena, but ngoba sekuhambe ama particles ashifta ngaka right nayo izoba ngathi ishiftela ngaka right, i-shape yakhe izoba kanje, right? So ubona ukuthi lena ikunika bani a greater surface area after i-activation energy. So njengoba ama particles maningi manje ashiftela ngala kusho ukuthi i-temperature yalo mkhulu ngoba ilithi ngizothi mhlambe i-temperature 1 u-temperature 2. U-temperature 2 mkhulu kune temperature 1 ngobani? Ngoba sibona ukuthi maningi ama particles ane energy enkulu kune activation energy for this one. Why is this kanjalo? Ngoba siyakhumbula ukuthi i-temperature will increase the rate of reaction. For the rate of reaction to increase, we must have more effective collisions per unit time. To have more effective collision, particle must have sufficient kinetic energy. So yabona ukuthi u-T2 wenza ukuthi ama-particles amaningi ashiftele ngaka-right. That means what? We have now more particles with energy greater than the activation energy. So le T2 usinika bani i-higher reaction. So temperature T2 mkhulu kune temperature T1. Into ebukayo ma interpreter ama distribution curves ka Maxwell wenze njani ubuka which one gives you a bigger area ngala after activation energy. It's all about kwenzekalani ngala, not ukuthi kwenzekalani. Unganaki shape ngala ukuthi ngoba low phezulu mkhulu kunalo. Wena naka ukuthi which graph ikunika bani area enkulu on the right side, right? So nala will be the same thing. Kodwa yakhumbula ukuthi i-temperature yona ayi-add ama-particles. Yenze njani i-increase i-kinetic energy ama-particles. Kodwa masibuka i-concentration. Wenzani ma u-increase i-concentration? U-increase ama-particles. So mase u-increase ama-particles kusho ukuthi na le graph izoshintsha ngoba kumele accommodate amanye ama-particles. So hlambe lesothi i-concentration 1. Mase increase ama-particles izothi kanje. Sesi increase ini ama-particles. So yabona ukuthi u-C2 mkhulu kuno C1. I-concentration ka le graph inkulu kune concentration. Ngoba le graph le sinika bani maningi ama-particles on the right side as compared to lama-particles on the first one. And why sitting inkulu ngoba siyazi ukuthi concentration, an increase in concentration will increase the rate of reaction. So siyabona ukuthi maningi ama-particles ane energy enkulu kune activation energy. Kusho ukuthi reaction rate yethu izoba high. Right? Mase siza la kwi-catalyst. I-catalyst yenze njani? Ilower i-activation energy. Yabona njengoba i-activation energy ela ikunika ama-particle hlambe awo 1 2 3 4 njengoba ngidwebe kanje. Now uma uthi faka i-catalyst izovela inciphise le activation energy ilethe la. Yabona ke suno catalyzed activation energy with a catalyst. Maso ne catalyst ayisekho la izala isondela ku 0 se izala. Right? Uyabona ukuthi bonke lama particles khathe la engakwazi ukufika ku activation energy. Manje activation energy siyayinciphisa ke siletha la. So kusho ukuthi bonke lama substance lama particles wonke ke se akwazini ukureact ngoba akwazile ukudlula bani i-activation energy. So the main thing is uba ne-energy enkulu kune activation energy. So that is how you work it out. That we understand ukuthi for activation energy, that is the main thing. Ama-particles, right, maningi after activation energy, then uzothi that reaction is faster. So this is the way Maxwell could actually interpret ama graph. Now into ebugayo most of the time kubuya hlambe kwi multiple choice nani ufana understand ukuthi into obonayo the one that gives you what an area enkulu after activation energy. So you look at that graph, the graph that gives you what a bigger surface after activation energy. Like ngala this graph T2 is nigabani area enkulu compared to T1. The graph C2 is niga ama particles ama noma so area enkulu kuno C1. Then ngala siyabona ukuthi the one with the catalyst, right, is niga bani ama area foot nakhona ngithi uyabona the first one without the catalyst, this is the only area una. But masufaka catalyst suya add phela kule area u add naloko. So maningi ke ama particles azoba nani ne energy enkulu kune activation energy, and then we say reaction rate yako is faster, right? So ngokwe reaction rate kumele ukunderstand ngalokho. Then into esalayo nje abafundi ngizotini ukuthi nithathe ama question papers past exam papers nibuke ukuthi niphendula kanjani lembuzo bese niyalandela ukuthi bengitheni and apply all the concept. Nizobona ukuthi I know nizoba right. Into enye yokugcina ke just to give you an advice. Mawukuthi umbuzo uza kuba investigative question. Right, maku in investigative question uyazi ukuthi bahlezi bazokubuza ini i-dependent variable, ini independent and ini i-controlled variable. Right, angithi manje uzama wena ukwenzani ukubona ukuthi masifuna uku-investigate i-reaction rate. Angithi lo question vele idila nani ne-reaction rate. Into engizokutshelayo ukuthi njengoba le topic idila ne-investigative question ngama-reaction rate, i-dependent variable yakho izohlezi ini rate of reaction. Makuthiwa write down the dependent variable, uzokhuluma ngani nge-reaction rate ngoba angibone enye into so-investigate ngaphandle kwani kwe-reaction rate, i-dependent variable. Mese kuba ama-independent nama-controlled variable. Right, independent and controlled variable. So mawubuka independent ama-variable sinawo ilama factors esasikhuluma ngawo: i-temperature, i-concentration, i-pressure, i-surface area, sibe ne-catalyst, siphinde sibe ne-nature. Angifuna umshiya nje ngaphandle u-nature even though asikhulumi ngaye for now in terms of collision theory. So independent, kodwa masifaka i-nature nakhona izoba independent. Ubukani vele bazokunika mhlambe experiment 1 kuthiwa lona i-concentration yakho 0.01, lona i-concentration yakho 0.02. Angithi uyabona ukuthi kuyashintsha ini i-concentration. Lento eshintshayo iyona i-independent. So if sishintshe i-concentration kumele ukuthi wonke lamanye ama-factors asale constant, wonke lamanye azoba ini i-controlled variable. Kodwa ke before usho ukuthi wonke lawa kumele wona are they applicable. Ngifuna ukukhombisa ukuthi ngesisikhathi akuwona wonke lama factors azoba applicable. Mangithi uzinc, angithi solid ureactor bani no HCl, sithi aqueous, kuskiphela bani uzinc chloride aqueous plus H2, that is a gas. Angithi uyabona into sidila ngolama factors kumele affecte laba, not ngala. So into sibona is solid. Kuma factors ngithi akhona awu2 athatha wonke, like i-temperature. Sithe temperature ingena wonke, kusho ukuthi i-temperature can affect the rate of reaction. Sikhulume ngani nge-catalyst futhi. I-catalyst nayo ingangena ku all of them, all. Mese kuba bani i-pressure. I-pressure ingena kubani kuma gases. Mawubuka le reaction akho gas ngala, asizi ngala ngoba this is a product, siza ngala. Kusho ukuthi i-gas is out kule reaction, awuzoyifaka kuma controlled variable. I-pressure angeke affect ini le reaction. Mase sikhuluma ngani nge-concentration. I-concentration ithatha gas noma aqueous. Masibuya ngala nathi aqueous, kusho ukuthi i-concentration can affect this reaction ngoba kune aqueous. And the last one was beside the surface area. Right, i-surface area ihamba ngani ne-solid. Njengoba ngibona i-solid kusho ukuthi i-surface area ingenze njani, ingayi-affecta lokho. So mawukuthi mhlambe ngishintshe i-temperature, example yami ngikhuluma ngani, ngishintshe i-concentration. Mhlambe experiment yokuqala ngisebenzisa i-concentration ka 0.01, yesibili ngisebenzisa 0.02. So ngiyabona ukuthi kuyashintsha lo i-concentration iyona eshintshayo. Lento eshintshayo iyona ini i-independent variable. Independent yet value izoba i-rate of reaction. So independent izoba i-concentration ngoba iyona eshintshayo between the two experiment. What will be the control variable? As ngeke sivele siwafake wonke lawa asele, sibuka ukuthi i-reaction i-pattern, i-reaction ne-solid, i-reaction in aqueous. So tata ke ukuthi i-temperature will be one of the control variable ngoba i-affect ngala. I-catalyst kumele ibe yot noma sifakanga at all. Asikwazi ukukhuluma nge-pressure, kodwa siyakwazi futhi ukukhuluma ngani nge-surface area. Kusho ukuthi masebenzisa i-powder zinc kumele sisebenzise i-powder zinc in both experiment. Ngiyathemba ukuthi niya-understand lento ngisho. Masikhuluma mhlambe i-temperature, i-experiment yokuqala basebenzisa 25 degrees Celsius, omunye usebenzisa bani u35 degrees Celsius. Njengoba i-temperature ishintshayo between two experiments, kusho ukuthi i-temperature will be our independent variable. Then the rest will be our control variable. The rest that are applicable, buka wena uyocheck ukuthi unani kuma reactant. What phases do you have kuma reactant, kuma substances kuma reactant? So then izokutshela ukuthi are you including catalyst, are you including pressure, are you including concentration, and so on and so on. Right? So mawenza kanjalo ke I know uzoba right. Right? So cabanga ukuthi sikhulume konke about ama reaction rate. Then sobonana ke next time. Asihlangane futhi next week, same place, same time, and sinifisela okuhle ke kuma exam end. Siyabonga.
Ningakhohlwa ukuthi nisengathokozela ezinye izifundo eziyisithupha kanye nezengeziwe i-learner wellness, i-career guidance kanye ne-advanced program. Hlanganyela nathi kwizifundo ezi-online ku-068 151 1072 noma ku-GoDigi@godigitalsa.today. Siyabonga.